Let's solve this equation. We'd like to get just one logarithm if possible. Here we've got log and a log. We do have subtraction, so we could use this rule. However, this 2 is a problem. It's not part of the rule. But we could get rid of it using this rule. We could put it up in the exponent. To get rid of a log, we exponentiate by the base. That's so we can use this. Our base here is 10. And if we do it to one side, we need to do it to the other side. So this becomes 10y over y minus 2 quantity squared. 10 to the first power is 10. We could multiply both sides by y minus 2 squared. Then we won't have anything in the denominator. We could also divide by 10 on both sides, so things can cancel. So we get y on the left side. On the right side, if we FOIL this out, we get y squared minus 4y plus 4. It's a quadratic equation, so we'll want to get one side to 0. This factors quite nicely. We get y equals 4 or y equals 1. Now with logarithm equations, you need to plug back in your answers and make sure they are in the domain. So if we put 4 in, we'll have log of 40, no problem. And 4 minus 2 is 2, log of 2, no problem there. So 4 works. Let's try 1, log of 10, no problem. 1 minus 2 is negative 1. And log of negative 1 is not a real number. So we're going to have to throw that one out, it's extraneous. And our answer is the set 4. We'd like to solve this. The trouble is we can't combine these because they're different bases. So let's put them into the same base by using the change of base formula. And we might as well just use a natural log. So we'll have natural log of x over the natural log of 3 plus the natural log of x over the natural log of 5 equals 7. Okay, notice we have 2 natural log of x's. So let's go ahead and factor them out. This part here is just a number. Let's go ahead and divide it. We have too many denominators going on, so let's go ahead and multiply the numerator and denominator by natural log of 3 times natural log of 5. So in our numerator, we just get 7 times the natural log of 3 times the natural log of 5. In our denominator, when we distribute this through, on the first one the natural log of 3's will cancel. And on the second one the natural log of 5's will cancel. So now we have natural log of x equals this. So to get rid of a logarithm, you exponentiate using the base. So let's use base e. So our answer is that x equals e to that expression, and let's get a decimal on that. Be sure to tell your calculator about the parentheses around the denominator. 96.589.